Welcome everyone to Pacific Hackers Conference. Today we have Rhea Vijh talking to us about product security, zero trust operations, and how it is essential to ensure that tools with privileged access adhere to best practices for their operational model. So Rhea, thank you so much.
Thank you for the introduction. Good morning, everyone. You all can hear me fine, right? Okay. Okay, my name is Rhea, and I'm a network security engineer at Google. In the era of automation and AI, it is important to secure the underneath critical infrastructure that applications run on. Network infrastructure is the backbone of AI, enabling efficient data transport, scalability, performance optimization, edge computing, and etc. Now, to secure the critical network infrastructure, it is important to secure the products that run the network. Today, I'm going to talk about product security. So today I'm going to talk about product security pertaining to products or software tools that have privileged access to the critical network infrastructure. As AI continues to evolve and become more sophisticated, the demands on network infrastructure will only grow. Investing in robust, future-proof networking solutions is crucial for organizations looking to harness the full potential of AI. One of the key factors in ensuring the robustness of the critical network infrastructure is to ensure these software tools that are used to operate the network are protected at every stage of their operation from both internal and external threats. This highlights the need for risk assessment and mitigation framework to enhance the security for products with privileged access to the network infrastructure throughout their operational lifecycle. One of the major risks that comes forth in this scenario is that these tools that are supposed to make the management and operation of these networks easier turn ballistic and get exploited intentionally or accidentally, causing damage to the network and the organization. This calls for the need to embed zero trust principles in building the risk assessment framework to assess and mitigate risks for these tools. Okay, here is a quick overview of the agenda I'll be walking through. Just a quick note, the presentation uses the word product and tools interchangeably, so that's what I'll also be using. I'll be doing a quick overview of the product lifecycle, followed by zero trust principles, and then dive into the risk assessment framework and the mitigations needed to reduce the risk. Just a quick overview of the product lifecycle. It starts with the design phase, then development or implementation, followed by tests and rollout, and then operations, and then finally evolution that can lead to decommission or it can lead to more improvements. Whenever we talk about product security, we mostly talk about securing the hardware and the software pieces of it. That is in the design and implementation phase. But product security has much more broader scope, encompassing operational and technical controls, the overall environment, as well as the mechanisms for detecting and responding to potential issues in product service. Attackers these days leverage weaknesses in development, testing, or operational phases, injecting malicious code or compromising tools and services. Today, I'm going to answer questions such as, what are some of the best practices we need to follow to secure the operation and maintenance phase of the product in terms of how it interacts with the critical network infrastructure? What are the access control measures in place? What are the execution control measures in place? And then that ensure the product is secure during its entire phase of execution. That is when it's making those critical changes to the network infrastructure. One of the fundamental principles of securing the operational life cycle of a product is zero trust. So So what is zero trust? We cannot trust any person, device, or bot in the entire life cycle of a product. There needs to be consistent authentication, authorization, and validation of access. There needs to be access control built in at various stages of the whole product workflow to ensure defense in them. We need to ensure there are only necessary access built in with the continuous logging and monitoring. These controls help us reduce the overall attack surface and provides us with increased visibility. Coming down to the risk assessment framework, this takes into account the following factors that I'll be going through and provides a comprehensive risk score. First is access, that is the access control measures to execute and maintain the tool. Second is impact, that is what is the scope of network infrastructure impact that the tool has scope for. Third is change management process, that is when the changes are being introduced in the network infrastructure, then what are the appropriate practices in place for that. Fourth is ensuring there are secure coding practices that are in place built into the tool itself while the tool is being developed or being maintained. Fifth is ensuring there is no sensitive data involved in the tool operations, and if there is sensitive data involved, then it is being appropriately handled. And last but not the least, the detection and monitoring capabilities in place for the product. Based on these factors I just went through, a quantitative model for a risk framework is considered that takes into account the vulnerabilities that exist in the system, combined with their impact analysis and likelihood of exploitation. And this assigns a risk score to each of the different metrics we'll go through just in a bit. These metrics will then add up to provide a cumulative risk score for the tool. With that numeric number, we assign a risk rating in terms of low, medium, or high. So the first one is access. There are three parts of access that I consider here. First is access control when the tool is executing on the network infrastructure devices or making changes to the network. That is access to use the product. Are there any barriers to unilateral access? Second is access control for the tool itself to operate on the network. How is the tool built to access the network? Third, maintenance access to the tools. That is, since the tool can make critical changes to the network infrastructure, then who all are actually allowed to make changes to the tool's code or package? Now coming to the tool's access to the network infrastructure. This is where we assign a risk score based on the questions like, can the tool be used to make changes to the entire network? Or is it restricted to only certain roles, regions, or segments? That's where we provide rating if it's partial access versus full access. I gave it a score 10 because this is a big impact. Then secondly, how is the tool accessing the network? Is there a direct connection using an RPC call or an SSH connection? Or is there programmatic access to the network that has additional guardrails or restricting ACLs built in? Next, coming to tools execution access. That is who all can execute the tool to make changes to the network infrastructure. Are there narrowly defined groups for executing the tool? How is the tool being maintained? Are there narrowly defined groups for who can execute the tool? Is there user justification enforcement for using the tool? Does the tool require multi-party approval when making changes to the network infrastructure? In addition, we need to ensure that the group membership for execution access is appropriately managed, like there shouldn't be permanent members. Folks leaving the company or the team should be automatically removed. Then maintenance access. This is for folks who have developed the tool and are continuously maintaining the tool. The folks who can make behavioral changes to the tool, So what are those? Who are those folks? Is there narrow access in there who can update the tool, like who can change the permissions to execute the tool? Is there code review in place, uh, or can anyone update the tool behavior and turn it malicious? Ideally, it should be a narrow group that makes or approves those changes to the code. Systems which support temporary ephemeral access are preferred across the board. Similarly, group memberships should be automatically managed, allowing specifics like organization membership, job role, managerial approval, training completion, policy agreement, etc. Next. Next, we come to the impact. This defines the impact the tool can have when it is being used. What all device roles it operates? Are those critical device roles versus non-critical device roles? Is the tool allowed to operate on all device roles? A device role will expose it to different levels of risk. For example, a device with user access, external connectivity, are exposed to more variable traffic than solely internal facing devices. Further, a tool constrained to a limited number of roles can have less of an impact radius than one with access to all. This makes the risk score subjective based on the placement of the device in the network and diversity of roles affected in the range of 2 to 10. The config change type defines the type of changes that will be rolled out to the device using the tool. For example, is it going to make routing changes to the network and can be used to divert the traffic, or can it be used to make to take the device offline for maintenance? This accounts for the impact to an org's products and services that the network infrastructure is serving, with a scope range of 2 to 10. Next is change management. This defines how the changes to the network devices are rolled out with the tool, asking if the tool follows basic principles of change management. This is a score range of 0 to 8, with if the tool is following all the principles, then it's 8, full, it's 0, partial is 4, and none is 8. Changes to the network should be progressively rolled out and not at once to reduce the impact radius of failure, and there should be monitoring and supervision in place for critical changes to the infrastructure. There should be a good enough test cases in place to ensure correctness before and after the tool, after the rollout is in process. In case of any failures, there should be provision to quickly roll back the bad changes, preventing propagation into the network. Next is secure coding practices. So SLSA is an open source framework for safeguarding the software supply chain. It is organized into series of levels that provides increasing supply chain security guarantees. This gives you confidence that software hasn't been tampered with and can be securely traced back to its source. Provenance, that is, the package has provenance showing how it was built. Can it be used to prevent mistakes? But it's trivial having only provenance is trivial to bypass or forge. The next level is hosted build. That is, builds run on hosted platform that guarantees and signs the provenance. Then third one is hardened builds. This means that the builds run on hardened build platforms that offer strong tamper protection. Next is secure data handling. This answers questions like, is there any sensitive data involved? How is it being managed, detected, prevented from being exposed? Data risk. Does the tool involve handling of any sensitive data? Now, the first thing that we need to do here is classify the data that we have, that the tool is operating. Are there any secret keys, passwords, protocol keys involved in operation of the tool, which, if compromised, can lead to unauthorized access affecting the confidentiality and integrity? Prevention. If there exists sensitive data, then we need to make sure that there are preventative measures in place to ensure it's not being exposed accidentally. Then detection. If the tool actually deals with sensitive data, then are there any detections in place to monitor that if any sensitive data is getting exposed to logs, dashboards, and other areas? The next one, detection and monitoring. Logging an audit trail is needed for conducting any forensics activity, debugging, and maintaining compliance. Usage logs. These determine how is the tool being used, any debug logs. Then second, access logs. Who or when actually accessed the tool? Is there user justification? When did they make the changes? When was it approved? All those things. In addition, there should be logging in place to monitor anomalous behavior. These checks help identify any deviation from the intended behavior of the tool or workflow early on before causing an adverse impact. Okay, too much information. To summarize the risk assessment, I have two examples. So what is a high-risk tool? A tool with full network access, capability to do any config change operations like traffic routing, taking the device offline for maintenance, and broadly open to all humans with anybody in the org, able to make those changes in the network without any approvals, checks, logins, and immediate rollout is the most risky tool and should be prioritized for remediation. Low risk tool, on the other hand, is a tool that has narrow access to only certain roles to perform only certain network operations with multi-party approval and review in process to perform a change that is tested and progressively rolled out with necessary logging and monitoring in place. So this is what a low-risk tool looks like. So what is the risk mitigation strategy for all these? Now that we have the whole framework and risk scoring in place, it's time to assess the tools based on these metrics and assign them a risk rating, and then classify them into high, medium, or low risk. This classification helps prioritize mitigation efforts and ensures that critical issues are addressed immediately while less severe ones are managed accordingly. During mitigations, it is important to identify the common themes that you see across all your domain of software tools and develop a list of mitigation actions required. This helps set up some baseline requirements so that we can prevent future mitigations. And last, and the most important one, is to collaborate with teams that own these software tools or products, make them understand the risk identified for these tools and get them mitigated. So this risk mitigation strategy feeds into setting up a software governance for these tools in the organization. This involves establishing and mandating product security standards for tools with network infrastructure access. Working with software development teams to enforce these standards at the design phase itself so that security is taken care of from the beginning. Ensuring continuous audit and monitoring of these tools against a set of controls we just went through to frequently monitor risks and mitigate them for various tools. Creating awareness and training amongst the organization staff and personnel who regularly operate these tools is also another important thing. So, in conclusion, few of the key takeaways I would like to highlight for building and maintaining secure products is first, narrow down the access. Identify the usage scenarios and ensure folks using these tools are well trained. Second, defense in depth. Ensure there are guardrails at every stage of the tool operation that are being continuously monitored and updated. Ensure there is sufficient logging and monitoring in place to help aid in forensics and developing baseline behavior checks for these tools. Last, having a continuous process of risk assessment and mitigation framework through automation. Thank you. Anybody has any questions? Oh, you have one.
So as a managed service provider, I don't really develop tools, but I have to implement tools provided by other vendors. How can I audit these tools to figure out which ones are actually following these guidelines? Which tools are kind of by my name?
So there can be automation built in, like in terms of, I think we need to, oh, sorry. So the question is that you have vendor provided tools and how you can monitor those so that to make sure the products are secure, right?
It's about choosing a tool. So how do I choose the SEIM tool? Know that these tools are correctly monitoring their security in there. As a vendor, I don't have visibility into how they're doing their risk assessments. We just have to look at their websites and pick what I like best. That feels so.
So I would suggest like creating a security standard in your organization that whatever tools you will be working on with these vendors, they have a set security standard that they should have these access control measures in place. They should have a regular vulnerability management in place. How is that vendor detecting vulnerabilities? When are they reporting it to you? Do they do zero-day vulnerabilities and all those things? And then how is the access to the network infrastructure for those tools? So I would recommend asking all, like setting up a standard in your organization and then asking all those questions to the vendors. If they meet it, then it's go. Any other questions?
For teams dealing with like sensitive security areas, is there any recommendations for how they operate better?
You mean teams dealing with sensitive information?
Sensitive information or like sensitive R&D?
So I think the most important thing is to classify the data. Like, what do you consider sensitive data? That's like the number one, right? And then making sure that that sensitive data is being secured. There's like a storage in place where it is stored, and it has like very limited access. It is being protected, right? And then I think one of the other things that I have not mentioned, but that's something we do is, so for all these secret information, like network infrastructure has all these secrets, the passwords and everything, right? And so we make sure that those are stored in a secret vault, and that is not easily accessible. And whenever we have these tools which are making deployment changes to these network infrastructure and they need to access these secrets, the tool itself accesses the secrets at runtime instead of hard coding those secrets within the tool. So that is, I think, something very important to have automation in place so that, and let the tool itself interact with another tool instead of, humans accessing and we are in the space, right? Any other questions? Cool. Thank you.